good morning to one and all. Welcome back again to another session of 8051 microcontroller, which is the part of the subject microprocessors and microcontrollers. I am Bhargav. So today, as part of the session, we are going to discuss about the topic called special function registers. As we already completed discussing internal RAM organization of 8051 and introduction of 8051. So now we are going into the topic called special function registers. So for that, let us go into the subject. So we already know that 8051 microcontroller is a versatile device known for its simplicity as well as its cost-effective products as well as powerful features. Now here, coming to the introduction part, actually again just as a mug-up, I am going to discuss what's the architecture. It is 8051 architecture is based on Harvard architecture, where program memory, where the code is saved, as well as data variables are stored, is called as data memory. Both the different memories, data memory as well as program memory, share a separate address space. Distinctly, there are separate address space. So that kind of architecture is called as Harvard architecture. 8051 memory architecture is Harvard architecture. So next, actually, that means we have a separate address bus for fetching the instructions, and fetching data, we have separate data bus if it is in the case of Harvard. So also organization of the memory on the chip, when you observe 8051 is having on chip ROM, we call it as program memory, and on chip RAM we call it as data memory, and special function registers memory or SFR region we call. There are separately called as special function registers. For that, memory is separately allocated. So now, if we want to connect an external memory, we can connect external RAM or ROM through a data cable with the help of ports. With the help of ports, we can interface a cable or data bus, a bus as simple as that. We can connect external RAM or external ROM, that means data memory as well as program memory. Also 8051 is having a powerful instruction set where it is always used for controlling different kind of controlling applications, where we use arithmetic and logical operations and data transfer operations also. So for that particular thing, we develop control applications using 8051 because of the instruction set. So coming to the next, that is our main topic of our discussion, that is special function registers. So special function registers are nothing but there are a separate memory locations dedicated to control specific hardware functions of the 8051. On hardware of 8051, on the chip of 8051, we have two timers, timer 0, timer 1. A UART device, that is universal asynchronous receiver transmitter, that is used for serial communication. Also, we have on chip some controlling features, on chip peripherals like ADC, analog to digital control, or digital to analog control, also ports and oscillator circuit, reset circuit, all different peripherals are there on the board. So in order to operate and control these functionalities, we have a specially allocated registers which are called as special function registers. For that, a memory location is present. So dedicated functions. See, special function registers are memory locations dedicated to control specific hardware functions within the 8051. And these special function registers can be addressed with the upper part of memory, where you observe internal RAM is of size 128 bytes. That means its starting address is 002, last address is 7F. That means this one is overall 128 locations. In continuation to that, there is an additional memory where the next address starts from 80F, 80H, that is hexadecimal address 80H, and the last memory location is FFH. So this is another 128 bytes memory location. These two, first one 00H to 7FH, 128 locations, that is 128 bytes memory, and 80H to FFH, it is another 128 locations, that means 128 bytes. That means one memory location can accommodate 1 byte of data. 1 byte of data. So, for special function registers, there is a separately allocated memory with the starting address 80H and FFH. So, these registers allow you to configure the operation of timers, serial ports, interrupts and other peripheral components which are present on 8051. So, here first of all let us understand how special function registers control the program flow. For program flow control, we have three different registers which are called program counter, that is a 16-bit register. It is divided into two different program counter higher, program counter lower, and stack pointer. Stack pointer is 8-bit stack pointer. It shows top of the stack, where for stack operations we use stack pointer. And another one is program status word, that is called as, otherwise called as flag register of 8051. Flag register of 8051. See, if you observe what is the function of program counter, it will fetch the address of the next instruction that is going to be fetched next. So, we know we will write programs, that programs is stored in ROM, read-only memory. Let us consider for the timing it is internal ROM. It has a lot of memory locations where all the instructions are stored here. If first instruction is of size 3 bytes, it will occupy 3 memory locations, that is first instruction. If the second instruction is 2 bytes, it will occupy 2 memory locations. Every memory location will be having a specific address. This address will be stored or it will be pointed out by program counter. If first instruction, that means program counter pointing to the starting address of the instruction. That program counter, once it point out, means that is the instruction going to be fetched next. So, program counter currently holding 0001, let us say 0001. So, here first instruction it is present over here, instruction 1, second instruction 0002, third instruction at the address 0003. So, first instruction where PC is pointing is holding the address 0001H. So, program counter, that is the that instruction in that address, first instruction in that address will be fetched. Every instruction will be fetched, decoded and executed. So, first instruction will be fetched. Automatically, program counter will increment its address to the next instruction where it is situated, that is 0002H. Again, if this instruction is fetched, again program counter will automatically increment to the next instruction's location. That means we can understand that program counter is a register that stores the address of the instruction that is going to be fetched next. So, program flow control, that means we can observe that program control counter is a special function register. Stack pointer is a special function register. Program status word is also a special function register. So if you observe, I already told you that from the address memory location 80H to FFH, special function registers are present, are stored actually in this region. Totally there are 21 special function registers, out of which 11 and 10, okay, 11 are bit addressable registers and 10 are byte addressable registers. Bit addressable and byte addressable. Bit addressable, every register, every special function register is of size 8 bits. So if it is a bit addressable register, 1, 2, 3, 4, 5, 6, 7, 8, right. If it is a bit addressable register, let us say this one is LSB and this one is MSB. Every bit is addressed. For example, for bit addressable, program status 4, as it is present over here, program status 4, that is the flag register of 8051, it is at the address location 0D0H. Let us say one location is there, 0D0H is present. In this PSW, program status 4 is there. Each and every bit is addressable. So D0, D1, D2, D3, D4, D5, D6, D7. D7. If I want to modify the bit of D1, I can use bit instruction and change the bit value of D1. That means I can make it 0 or 1. 1 or 0, I mean. So that is bit addressable registers. So here for stack operations, stack pointer is a register, that is also a special function register. It will use internal RAM, which is of size 128 bytes for stack operations. For stack operations, stack pointer is a register, that is special function register. It will use the memory internal RAM for stack operations. So let us consider that this is 128 bytes memory with the starting address 00H to the last address is 7H. So stack pointer by default or upon reset, it will be only showing 00H. If you push, there are instructions like push and pop. If you use push instruction, a data will be moved onto the stack. If you pop that in, if you use a pop instruction, data which is previously moved or pushed onto the stack, it will be retrieved back. So we can push accumulator data, either it's 8-bit register data. B, you can push anything. If you use this instruction push A, accumulator data will be present over here. If subsequently if I use push B, next location 01H pushed, B will be data will be present in this location where 01H is pointed out by SP, that means stack pointer. If I use push port 0 content will be present on 02H. This address is pointed out by stack pointer. So stack pointer at the moment, the top of the stack is 02H and the pointer, the last top of the stack will be the contents of port 0. So actually, so this is a general application or explanation for stack operations, but in reality 8051 microcontroller, you will be having internal RAM of size 128 bytes, starting address 00H, 7FH. Here let us consider this is 07H, 01, 02 and so on up to 07H. So our stack pointer by default or upon reset, previously I told it was 00, but actually in reality stack operation starts from 07. That means upon reset or upon power up, SP stack pointer is configured at 07. That means SP will be pointing to 07H. If I use push A, push B, push PSW continuously, obviously A will be pushed on to this address 08H, and to this address B will be there, and next address is 09, PSW will be there. So this address, for every push, stack pointer increments by 1 for every push, and for every pop, stack pointer decrements by 1. So that is how stack operations are done. So in this manner, program control, program counter, stack pointer and program status word all are special function register. See, coming to program status word, it is a 8-bit register. Its address in SFR region as in 80H2 FFH is 0D0H. Okay, let us break it into pieces like 8 bits, 1, 2, 3, 4, 5, 6, 7 additional. So let us consider this one is LSB and this one is MSB, most significant bit and least significant bit. So to start with, generally there are 5 flags, almost 5 flags are there. First one is overflow flag, overflow. Next one is parity. Next one is 0 flag will be there, and remaining 2 flags will be overflow, parity, 0 flag, and there is no interrupt flag. Interrupts will be there. For interrupts, particularly timer. So generally there are flags will be there. It will show the condition of the situation where by instructions execution we can check the timer is overflow or not. If it overflow interrupt will be given. If it is parity in the sense for serial communication, you can go check even parity and odd parity for error detection and error correction, and you can check also whether there is the operation that succeeded leading into 0 flag. If the result is 0, we can assume that it is a 0 flag. 0 flag will be set, and in this manner flags will be there. So PSW or program status word is a special function register. See here, actually program status word contains overflow flag as well as carry flag, 0 flag and parity flag, and another flag is also there. So these are the flags present in program status word. So these conditions shows the status of the CPU. That means it will give you whether 0 flag, currently whether 0 flag is set, a carry flag is set, sign flag is set, parity flag is set, overflow flag is set. So coming to the special function registers, these are the special function. Previously these are the special function registers for particularly program, changing the program flow. If a program is executing one step by one step, we can also alter the program's control with the help of these registers. Also, another concept is called as special function registers, particularly for timers. So there are 2 timers in 8051. Additional timer 2 is an optional. So timer 0 and timer 1 both are 16-bit timers, and divided into timer 0 lower, timer 0 higher, timer 1 lower, timer 1 higher. 8-bit, 8-bit, 8-bit. All are 8-bit registers. All are 8-bit registers. So actually, the main purpose of a timer is to provide precision timing and provide delays. Where timer 0 is a general purpose timing. I used to count the events and clock pulses. It does operate in different modes. And also timer 1, it will provide you more advanced functionality by capturing the events and providing a precise delays. So actually timer 2 is an optional concept in timer 8051 microcontroller. In 8051 microcontroller, by the standard flavor of Intel, which was manufacturer, where there is no presence of 80 timer 2, but timer 2 in the latest very next flavors of 8051, there is a presence of 8051 that works in combination with another timers. So serial control, that means special function registers mainly controlling serial communication. What are the registers are there? If you observe, coming back to timers, if you observe, there are two registers. Actually, there are two registers. One is timers Tcon and Tmod. Tmod and Tcon. These two are called as timer mode and timer control. Timer mode, it will change the mode of operations, where there are four mode of operations: mode 0, mode 1, mode 2, mode 3. We can change the mode of operations with the help of timer mode register, and we can also change the control. Timer related flags will be there, timer related interrupts will be there. Timer 0 interrupt is timer 0 interrupt, timer 1 interrupt, that means overflow, timer overflow 1 and timer overflow. Overflow interrupt for timer 0, overflow interrupt for timer 1. These are the two interrupts we can control with the help of this particular timer control register. Again, we can also change the signal type, from which signal the interrupt should be triggered. We can change the type of signal that triggers the interrupt. So, timer control precisely consists of the run bits. Timer 0 run and timer 1 run. If you set these two bits, timer will start automatically and start counting the pulses or external events. Once it reaches the maximum count, it will overflow eventually. Every overflow is indicated by an interrupt. So, every timer 0 and timer 1 will be having associated overflow interrupts. So, whether interrupt came or not, we can come to know that from Tcon, where Tmod is only we can change the mode of operations, whether it is mode 0, mode 1, mode 2, mode 3 for both the timers, timer 0 and timer 1. So, we can study exclusively about the mode of operations and timer control registers in the next classes, next sessions. So, coming to the next topic, that is special function registers that are incorporated in serial communication. Serial communication is nothing but, let us consider this is one device 8051 and this is another device 8051. If you want to send a data from this device to another device, either you can send by connecting 8 by 8 bit bus. 8 bits will be traveled on once at a time. This is called as parallel communication. Whereas, if you do the same connection with a single link, this is a multiple link and this one is single link. If you are trying to send data from one device, let us consider 8051 on one end and another end is also 8051. If you want to send a data serially, but with a single link, we can send data first LSB bit after bit from this device. So, here there are two registers particularly 3 registers are there for responsible for the operation of serial communication in 8051. UART is the circuit where it will have serial buffer register, another serial control register and power control register. These registers are special function registers that are responsible for handling serial communication in 8051. So, here buffer register will be along with the circuit, that is SBUF with UART, Universal Asynchronous Receiver Transmitter, that will convert internal parallel data into serial. See, let us say whatever the data I want to send, I will put the data in accumulator, that will be a parallel data, that will be moved on to special SBUF. Automatically it will be converted into serial, parallel to serial. It will come out, it will travel one bit after the other on the single line. Again, upon reaching, there will be another SBUF here. Upon reaching, it will come to SBUF. Again, it will move to accumulator of second device. So, this is first device, second device. it will be serial in and it will be stayed as parallel data. So that's how it is responsible. SBUF. SBUF is serial buffer register. If we keep any data in, it is automatically ready to transport the data serially from one device to another device via a bus or a single bus line. So another register, serial control register. Serial control register, it will have SM0, SM1, SM2, receive enable TB8, RB8, TI, RI. These are the different bits. This is a 8-bit register, that is SCON. This is also a special function register. These two, this is MSB and this one is LSB. SM0, serial mode 0, serial mode 1. SM2, serial mode 2, that is used for multiprocessor, multi-device communication, like this, multi-device communication. So, receive enable, if you enable it, other device is ready to receive the data. This is transmit bitrate and transmit receive bitrate, transmit TI, transmit interrupt and receive interrupt. So, this is generally the structure of serial control register. This particular serial control register mainly focuses on 4 modes of operation. 8051 serial communication does its operation in 4 different modes. As I told in timers, there are 4 modes of operation, as well as in serial control, serial communication. It has 4 modes. Mode 0, mode 1, mode 2 and mode 3. Mode 0, 1, 2 and 3. So, the data with which transfers from one device to another device serially will be at a particular rate it will transfer. That particular rate is called as baud. So, 8051 is a 8-bit microcontroller. At every instance, a 8-bit data will be traveled. So, you consider 8-bit data with LSB first, followed by first bit, second bit, third bit, fourth bit and last one is 7th bit, that is MSB. You consider this particular group of 8 bits as one baud. One baud means BUAD, baud. It is considered as a droplet. If you observe droplets of when rain is falling down, droplets from house when it falls down, in the form of droplets it will fall. So, you consider one droplet as 8-bit. That is called as a baud, 8-bit baud. If the current in rainfall rate is increasing, the baud or the rain droplets falling down towards the down earth, it will be very faster rate. If the rain is slowing down, the falling of these droplets rate also decreases. That means serial communication, when the rainfall is heavy, the droplet speed will be also high. If the rainfall decreases, the droplet speed also decreases. In such a manner, we design a rate called as baud rate, where this particular 8-bit data from device 1 is moving to device 2. It is baud rate. So, this baud rate is defined by SCON, and whatever data that is going to be transferred and received, it will be taken care of by SBUF. And power control. Power control is a separate register. It is not mentioned here. Power control is a separate register. Mainly, it focuses on increasing, doubling the baud rate and changing ideal mode and power down mode, we can keep it. So, if for particularly this concept is concerned, we can have a special session on serial communication in 8051 microcontroller. So, moving on, and there are 2 registers which will we consider as special function registers, mainly handling interrupt operations. There are 5 interrupts. External interrupt 0, timer overflow interrupt, external interrupt 1 and timer 1 interrupt, and the serial communication interrupt. This is the priority order. So, 8051 when externally connected to multiple devices, internally timers are there, UART serial communication circuit is there. Internally we have 3 interrupts. This one is these 2, IE0, external interrupt 0 and external interrupt 1 are external interrupts coming from external devices D1 and D2. So, interrupts are nothing but these are separate programs that come and request the CPU's time, where the central processing unit is executing internal program. When an interrupt comes, if it is of high priority, the program counter currently executing the main program, it will, let us consider PC at this location, ROM, this is ROM, program is present over here, PC is executing one instruction after another instruction, program counter is at current location as described in this diagram. See, IE came, IE 0, external interrupt 0 came. It is of high priority, PC must acknowledge. PC, it will store the current address of this instruction that is executing currently onto the stack, and important variables, whatever the variables you used for the previous instructions execution, like A, B, ports, any information that you used in the previous instructions, it will be also, all these are also moved onto the stack. And the program counter, it will change its course from the main program to the interrupt, whatever the interrupt is there. Every interrupt will be having a separate program and stored in some other location apart from the main program's location. So, every program, subprogram is called as ISR, interrupt subroutine. Program counter, it will transfer to all the way from main program to execute or acknowledge the interrupt which came. So, whatever the interrupt come during the main program's execution, based on the priority, it will hold, it will store the data onto the stack and change its course. It will move to the main subroutine location and execute. And again, once after the program's execution is done, last instruction return will be there. Upon return, context switching will happen. It will again come back to this PC's location where the previous location got disturbed. And while it comes, context switching takes place. That means whatever the previous information you stored onto the stack, it will be retrieved back. That's how it is done. So, if let us assume all the interrupts are all at once came while the main program execution is taking place at the moment, based on the priority order which I mentioned, 1, 2, 3, 4, ISRs will be executed. That's how it is done. So, in order to change the priority, interrupt priority will be, register will be used, and in order to enable or disable, if you enable, all will be enabled. If you disable it, main program execution will be going on in its own course. If you disable it, so we can on or off using interrupt enable, and we can change the priority order which I mentioned over here with the help of interrupt priority. So, these are the interrupt registers mainly considered as special function registers. So, and there are 4 ports, port 0, port 1, port 2, port 3, all are 8-bit ports, all are bit addressable. These are considered as special function registers. You know, port 0 and port 2, generally they are used as bidirectional input and output ports, and sometimes they are used for connecting external memories. And port 1 exclusively, it is used as bidirectional IO port, and port 3, it is used as IO port, also it has special functions. So, we will have an exclusive session on timers operation, serial operation and ports operation in the next upcoming sessions. So, now, as idea, special function registers are separate registers. 8051 is having 2 types of registers, general purpose registers and special function registers. These general purpose registers are present in internal RAM itself in the form of R7 to R0 to R7, 8 bits, 8-bit registers, 8-bit registers spread across 4 register banks, RB0, RB1, RB2 and RB3. These are general purpose. Apart from general purpose, there are specially function registers are there which are 21 in number. So, if you write want to write 21 in number, you can write A, B, accumulator, B register, program status word, program counter higher, program counter lower, data pointer higher, data pointer lower, stack pointer, timer 0 lower, timer 0 higher, timer 1 lower, timer 1 higher, tmod, tcon, sbuff register, scon register, power control register, IE, IP, port 0, port 1, port 2, port 3. So all these are 21 special function registers, especially controlling each of their own operations, serial communication, timer control, interrupt control, program control, all these things. So, you know the applications of 8051 mainly used in industrial, automotive and home automation. So, this is the end of the session. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.